Hi, this is Jay McClellan. This video is part 2 of my project to make a micrometer dial using the XAxis assembly that I built in the previous 2 videos. Part 1 of this set was designing the part in Fusion 360, doing the CAM toolpaths, and generating the G-code. And in this part 2, I'm actually going to make it. I mounted my stock in the lathe and faced it off, and next I'm going to drill and tap it for the 7/16 20 threads that it needs inside. I'll tap it by hand using a short dowel in this tailstock to get it aligned straight. I drilled and tapped the hole, and now I'll clean up the outside surface of the part. I want to do this last in case the part shifted a little bit while it was being tapped. So this will give me a surface that should be concentric with the rotation of the chuck, and I can move that to the 4th axis. Now I'll carefully remove the chuck from the lathe, leaving the part in position in the chuck. I have the 4th axis mounted to the bed of the CNC Shark router, and for this operation that I'm about to do, the alignment is not highly critical, so I just aligned it visually with the edge of the slats in my spoil board. I have the part still in the chuck that I carefully removed from the lathe, and I'm going to mount that on the 4th axis now. And anytime I mount a chuck to a faceplate, I have an index mark on both the chuck and the faceplate, both on the 4th axis and also on the lathe, so that I always get the chuck back in the same orientation and not off by 1/3 rotation. That should help reduce run out and should make it consistent each time I mount it. This is a good opportunity to check the run out comparing the mounting of the chuck between the lathe and the 4th axis. If I did a good job machining the faceplate on the lathe and the faceplate on the 4th axis, then moving the part from one to the other should give me a very consistent positioning. So I put this dial test indicator on the side of the part that I machined on the lathe, and I'll rotate it on the 4th axis now to see how the run out looks. So rotating through 360 degrees, I see a total indicated run out of about 4/10. That seems pretty good. I shut the CNC controller off, and now I'm going to swap the connectors for the X and A axes so that I can drive the 4th axis from the X-axis output. I'll still connect the X-axis output, the X-axis stepper motor, to the A-axis, even though I'm not going to use it. I'm not going to move it because having it connected will energize the stepper motor and hold the X-axis in place. If I didn't do that, the gantry could move side to side a little bit, and I don't want that. So having the same current rating on all the stepper motors makes it very simple just to swap these electrically. My CAD model uses a circumference of 75 millimeters for the part, and I need to configure the CNC controller so that the 4th axis, which is now the X-axis, will rotate exactly 360 degrees when the X-axis moves by 75 millimeters. I'll do that using the settings page, and on the settings page there's a setting called X-axis pulse equivalency, and that's set in pulses per millimeter. And so when it moves 75 millimeters, I need to provide the correct number of pulses to rotate the 4th axis 360 degrees. My stepper motor has 200 steps per revolution, and I have the microstepping driver set for 1/16 microstepping, which means I have 200 times 16 equals 3,200 pulses per revolution of the stepper motor. I have to multiply that by 45 to get the total number of pulses to rotate 360 degrees. That's 144,000 pulses. If I divide that by 75 millimeters, which is my circumference, I get 1,920 pulses. That's the number I need to set here in the pulses per millimeter. That should give me a revolution of 360 degrees when the x-axis moves by 75 millimeters, which is the circumference I used in my CAD model. I'm going to check my setting for the x-axis pulses per millimeter to make sure that moving the x-axis 75 millimeters actually rotates the part 360 degrees. I have the x-axis zeroed out, and I drew a mark on the part so that I can tell when it's rotated exactly 360 degrees, and I'm going to rotate the x-axis with the manual pulse generator wheel up from 0 to 75 millimeters. Looks perfect. I raised the Z-axis 2 millimeters above the part and zeroed it out, and I'm going to do a test run of the ticks subprogram to check how it engraves the tick marks before I run with the actual part and with the spindle going. So here goes. That looks good, so now I'll run the real program. The tick marks look great. They came out exactly the way I wanted. They're spaced nicely. They end correctly, so very happy with that. Now that the tick marks are done, I've loaded up the program to engrave the text, and I'll run that next. The text looks okay, but it's rather faint, and I want it a little deeper than that. So I just re-zeroed the Z-axis so that it will cut 1/10 of a millimeter lower, and I'll run the program again and see how that looks. I carefully checked the Y travel to make sure that the router bit is not going to hit the chuck when it comes to the top of the knurl program. It's very close, but there should be a couple of millimeters of clearance. So I'm ready to run the knurls now. Here it goes. By now you may have spotted the silly mistake I made. The text is backwards. That should say 10, not 0 and a backwards 1. The numbers are backwards because when I increase the x-axis in a positive direction, relative to the part, the bit is moving to the left, and that's backwards. So, not a big deal, but I'm going to have to redo it because I have to reverse the directionality of the x-axis in order to rotate the part in the direction I need. Using the same chuck on the metal lathe and on the fourth axis has the advantage of not having to buy two chucks. But the biggest advantage is that I can move the chuck between the two machines without removing the part from the chuck and maintain my registration. So I've taken the unit from the 4th axis, I've put it back on the metal lathe. I'm going to turn off the engraving that I just did, reduce the diameter of the part slightly, and then I'll be able to redo the engraving. There we are, all back to a clean slate, very slightly smaller. Fortunately, the diameter of the wheel is not at all critical for this project, so this should work just fine, and I can try again. To reverse the rotation direction of the X-axis, I'll simply change the X-axis directional signal electrical level, and all I have to do is change it from low to high, and now the X-axis is reversed. I have the part remounted on the 4th axis, and I've reset my Z coordinate to match the new slightly smaller diameter of the part. I also took the opportunity to go in and tweak some of the dimensions in the CAD model to make the text just a little bit bigger and make some of the tick marks a little shorter and the knurls longer. So I'm ready to cut the tick marks now. Now I'll run the program to engrave the text. I don't know why the Fusion 360 toolpath chooses to engrave all of the 0 digits first and then go back and engrave the other digits. Doesn't really matter, the text looks good, so I'm happy with that part. Finally, I'll run the program to engrave the knurls. My first attempts to machine this part didn't come out very well because I was getting a very inconsistent depth of cut, and as the Z-axis moved up and down when the part rotated, I found that by the time it got around to the other side of the part, the cut height was quite a bit different. And I used a dial indicator to test that, putting it under the Z-axis, moving it up and down, and eventually figured out that the problem was that the Z-axis was losing steps, where I could move it up and then move it back to supposedly exactly the same position, but it would not return to the same physical position. And this is a real common problem with stepper motors. Usually it's caused by trying to accelerate them or move them too fast, where they will physically lose steps. They can't keep up with the signals they're getting. But I slowed things way down and the problem persisted, and eventually I figured out that it was not a problem of moving things too fast, but rather pulse signals were being sent by my CNC controller faster than my relatively inexpensive stepper motor controllers would handle. Originally I had used fairly inexpensive stepper controllers, and I upgraded them with much beefier stepper drivers from Automation Technologies, and that completely cured my Z-axis movement problem. With these higher end stepper drivers, things move much more smoothly and much more consistently, so I'm very happy with that. My first two attempts to engrave the part didn't turn out all that well, and after each failed attempt I took it back to the lathe and turned it down below the level of the engraving I had done. So the diameter of the part is a little bit smaller than I had intended originally, but not by that much, and it should work fine for its intended purpose. This test now is with my upgraded stepper drivers, upgraded power supply. I've tweaked the settings to reduce the acceleration of the axes, so I think I have things tweaked in pretty well, and I think there's a good chance this one's going to work. Now I'm going to run the program to engrave the tick marks. The part is now slightly smaller than the 75mm circumference that I used in my CAD model, but that doesn't really matter much. It makes the tick marks a little bit closer together and compresses the text slightly, but otherwise it doesn't really change the usability of the part because the tick marks are cut at the proper angles. If I were machining a part where I needed exact dimensional tolerances around the circumference, then I'd have to go back and modify the CAD model to account for the physical circumference of the part. Well, the tick marks look great. Well engraved, just at the right depth. They're nice and smooth, and they met exactly where they were supposed to meet at the end. So far so good. Now the tick marks are done, I will engrave the text. Well, the tick marks and the text are done, they look good, so now it's time to do the knurls. This is the part that gave me the most problem last time, where I had inconsistent positioning of the Z-axis. So what I'm going to be looking for is a consistent depth of knurling all the way around, so that when it comes back to the other side it should meet exactly the same, and there shouldn't be any visible difference in the knurl from one end to the other. Well, I'm pretty happy with the result. There's maybe a tiny visible difference on the knurl right at the seam. You can kind of see it there, but it's really tiny. And in general, the knurls look good, the tick marks look good, and the text looks good. So I think this step is done. Now I'll take it back to the lathe to part off the knob, and I'm still going to be very careful not to disturb the part as I take this off, to leave its registration in the chuck jaws, although it's not all that critical at this point. And in fact, I may need to move it out a little bit just to have enough room for the parting tool to get in. I'll just unbolt it from the 4th axis and then take it over to the lathe and bolt it back on the faceplate there. I noticed that I have just a tiny bit of a burr on this end where the tick marks were cut off this edge, and so I'm going to face this off again just to clean it up and put a tiny chamfer on that edge before I part it off. Once again, this is really nice, being able to maintain the registration between the 4th axis and the lathe. I did have to move the part out just a tiny bit in the chuck just to give clearance for my parting tool, but I don't think that's going to cause a problem. It's still well aligned. Here's the finished part, and I think it came out pretty good. It's certainly very usable, but there are a few things I'd like to improve in the future. The knurling, if you look closely, is a little bit rough, which really doesn't matter for its intended purpose, but I don't think it looks nearly as good as diamond knurling done on a lathe. So that's an area where I may try some different techniques in the future. The text is readable, but the bit that I used was a combination drill and countersink, and it has a little flat on the bottom, so all of the grooves, knurling and text, are flat bottomed. That may be okay for text because I'll probably fill those in with some paint to give me better contrast, but a sharp pointed V-bit might work better in the future. Also, if you look closely at the text and the tick marks, look at the top of the tick marks in this view. You can see they're not quite symmetrical, and that's purely cosmetic. It won't affect the function of the part, but I think there's a little bit of deflection of the bit when it cuts on one side versus the other as it's making the little flare at the end of the tick mark. So little subtleties won't affect the usability of this part at all, but things I'll try to improve in the future. That concludes the first project done on my new 4th axis for my CNC router. You got to see some things that worked well and a few things that didn't work so well, and some of the problems I had along the way. So I hope you found that interesting, and thanks for watching.